Course 2, Lesson 8, Fractions and Percents, and also the inch ruler. The objectives from this lesson are going to be the use of fractions, percents, and mixed numbers to name a part of a whole. Use a ruler to measure segments to the nearest 16th of an inch and determine the precision of a measurement. This is your vocabulary that you need to learn. You know where to find it in your course study. It's there to be printed out. Fractions and percents are commonly used to name parts of a whole or parts of a group. This picture over here, the circle itself represents 1, and then it's been divided into 4 parts. And of those 4 parts, 1 part has been shaded. The other 3 parts have not. Well, if we take that whole part and we divide it by 4, we know that 1 part equals 25%. So if we subtract 25 from 100, we know that this unshaded portion here is equal to 75%. A common fraction is written with 2 numbers and a division bar. This is what represents the shaded portion in our picture above. 1/4 of the whole is shaded. The top number is the numerator. The bottom number is always the denominator. A percent describes the whole as though it were 100 parts, even though the whole may not actually contain 100 parts. Thus, the denominator of the percent is always 100. So in our example before, 1/4 or 25% of the circle was shaded in. So we would show that as a fraction, we show that as 1/4. As a percent, 25 over 100 is 25%. A mixed number such as 2 3/4 includes an integer and a fraction. The shaded circles below represent wholes. So there's a 1, 2, and 3/4. So we'd say that 2 3/4. It's possible to have percents greater than 100%. In our example above, when we write 2 3/4 as a percent, we write 275%. The reason we do that is because this equals 100%, this equals 100%, and this equals 75%. So when we add those all together, we get 275%. Name the shaded part of this circle as a fraction and as a percent. Go ahead and do that, then let's do it together. 2 of the 5 equal parts are shaded. So if you count those up, 1, 2, 3, 4, 5, we know that 2/5 is going to be our fraction. Now, the percentage part, since the whole is 100, and we divide 100 divided by 5 parts, we know that comes out to be 20. So we know that each one of these is equal to 20. So our percent of shaded area is going to be 40%. 40 over the 100. Which part of this, which of the following could describe the part of this rectangle that is shaded? Is 1/2 of that shaded? Is 40% shaded, or is 60% shaded? And how would you know? There is a shaded and an unshaded part of this rectangle up here, but they're not equal. The parts aren't equal. More than 1/2, we go to half about right there, right? More than half of that is shaded. So the answer is not A. It can't be A. That's not right. And because we know that half is 50%, we know that the shaded part's more than that, so it can't be 40%. So we know that this must equal 60%. So the correct answer was C. Between the points on a number line that represent integers are many points. So if we look at this number line here below, it wants us to find out what the mixed number is, represented by point A. Well, we already know that we have how many whole? We have 8 wholes. But if it's a mixed number, that means we have over here we have a fraction. What's that fraction do you think that fraction is going to be? See if you can do it on your own. If we count the sections between 8 and 9, we have 1, 2, 3, 4, 5 sections. And A is sitting in here's section 1, section 2. So we know that A is on 2 out of the 5 sections up here. So our answer should be 8 2/5. Let's see if we're right. Hey, there we go. 8 2/5. It's important to focus on the how many segments there are, how many spaces there are, not just the line. So for example, if I go like this here and I go 1, 2, 3, 4, I have, okay, so if you just went 1, 2, 3, 4 and said 2/4, that would be wrong because there's really 1, 2, 3, 4, 5 sections between those lines. So don't just look at these marks right here, these straight up and down. Don't just count those hash marks because that'll confuse you. You got to know how many sections there are. In this case here, there's 1, 2, 3, 4, 5. A ruler is in all practicality a number line. The units on a ruler are standard length, and as you can see one down here, an example, it's magnified. Bear in mind that all measurements are approximate. The quality of measurements depend upon many conditions, including the care taken when you measure and so forth. Some instruments, some rulers will have even smaller hash marks in between them. But I think all of you know how to use a ruler. I can work with each of you individually if you need help with that. Let's how would you arrange these fractions in order from least to greatest, and how would you know? Well, let's think this through a little bit together. We know what 1/2 is. So if we've got 1/2 right there, 1/4 we know is less than 1/2. We know that. Now 5/8. What's half of 8? It's 4. So is the 5 bigger or less than a 4? It's bigger. So 5/8 has got to be bigger than 1/2, because 1/2 would be 4/8. And then 7/16. What's half of 16? Well, it's 8. So 7/16 must be smaller than 1/2, because half would be 8/16. So 7/16 must be right there. So I'm thinking that our order is going to be 1/4, 7/16, 1/2, and then 5/8. Let's take a look and see if that's correct. One-fourth, 7/16, 1/2, and 5/8. Very good. I like it when we do it right. Here's your tickets in the door. Please work these problems, submit them to me tonight, and we'll see you tomorrow in class.